Now we have the seasonal index. We have estimated the seasonal index for each of the 4 seasons for this data. We have 4 seasonal index values. If this was a monthly series, then you would have 12 of these. Okay. Now, to determine these seasonal index values, we first estimated what the trend would be by averaging out the seasonal effects, and then by subtracting the trend component out of the actual values, we were left with the seasonal part alone. Okay. Now we have to estimate the trend, and for that what we're going to do is we're going to take the actual values and subtract out the trend that we have estimated now. So what will remain is only, we'll subtract out the seasonal indices. So what will remain is only trend. Because we are doing subtraction because this is an additive model. Okay. Otherwise we'll be dividing. Subtraction is dividing, adding is multiplication. Now we can do this starting from year 1, because now that we have the seasonal index for the 4 seasons, so that's the first quarter, and we copy that for quarter 2, 3, and 4. Then we have the 4 quarters. So let's put that line back there. Okay. Now we need these 4 to repeat for year 2, year 3, and year 4, and we can accomplish that by simply copying 4 seasons back, 4 periods back, because this is a quarterly series. Okay. So now if you copy this all the way down, okay, then we'll put the border back. Then what we get is the 4 seasonal indices repeating itself. Okay. Now since this is an additive model, then we take the actual value of the series and we subtract. Okay, we would be dividing here if it was a multiplicative model. Okay, so now that is simply the seasonal part of the time series. Okay. We can see this by plotting. This is the actual series, right? And then this is the deseasonalized series, which is supposed to have only trend. And if we plot this, we'll do a line plot. Okay. And you see the blue line is the original value. Okay. That's series 1 is the actual series. Series 2 is the deseasonalized. In other words, that's our trend. So we have and as you can see, the deseasonalized value is free of all the seasonal fluctuations. Okay. Now with this as the starting point, now we can set up a trend model. So LES model, we have done this before. So where we set up the initial values as what? Y sub 3 minus Y sub 1. Okay, Y's here would be the deseasonalized values divided by 2. And then we have the average of these. This is from chapter 2. Okay. And then trend forecast is that plus that, and the error is then, okay, remember the deseasonalized value minus the trend forecast gives you the error. Okay, now we can set up the level is forecast plus alpha plus F4 times the error. Of course, we need to set up initial value for alpha, let's say 0.1 and 0.2. Okay, and the trend will be previous trend plus beta times L minus F. Okay. Now we copy these. And that will be our trend. Okay. So these are the trend forecasts, and these are the seasonal factors. So in an additive model, then take the trend forecast and add the seasonal trend to it, seasonal index to it, then we get the forecast. Okay. Now, of course, we need to set up the error measures for the forecast, and then we can run solver. Okay. So now that we have the series forecast determined, okay, let's set up these forecast error measures, and this is going to be for year 2 quarter 1 to year 4 quarter 4. Q4. So that's what we're going to use as the range. So MSE will be MSE of actual values, so starting from here, comma, the forecast comes from column M, so that gives us the MSE, and with the same range then we can set up MAE, MAPE, or MSE. Okay, so here is MAE, and we have MAPE, same range, and then we have RMSE. Now for MASE, okay, the first two ranges are same. The third range is the naive forecast. So forecast for year 2 quarter 1 through year 4 quarter 4, we have to go back one full season, so it will be year 1 quarter 1 through year 3 quarter 4. So that will give us the MASE, and same range for Thiel's U. Okay. So now we are ready to run solver. So go to solver. Okay, now obviously we need to really run a couple of solvers, one with RMSE, one with MAPE, and so on. We'll just do one. RMSE want to be minimized, and alpha beta, add alpha beta less than or equal to 1. Okay, non-negative GRG nonlinear, so click OK, and here we get the values, and as you can see, the MASE and Thiel's U are really great, and we have very good forecasts for this example for data. Of course, since the data set is small, we don't have a holdout sample and the estimate sample here. Everything is 1.